All right, so your warm-up is review, especially number 1. That's review from last semester, but a couple of things I want to talk about going into today and tomorrow. So this says solve the function. So obviously it's the quadratic. So if you're trying to solve, excuse me, you have, obviously we're going to make this 0. I would look at this and try and factor it first. But looking at it pretty quick, you can see that factoring is not going to work because you're adding in both cases, and 13 is only 1 times 13, and I can't add 13 and 3 to get 10. If there was a subtraction sign in there, then I might give factoring a try. I'm not going to complete the square because I have a 3 that I would have to take out. 3 doesn't come out of 10 nicely. So I'm going to move on to quadratic formula, which we all know is not my favorite. However, sometimes necessary, which it is in this case. So we have x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So remember, you always want to do your discriminant first, which we're going to talk again tomorrow about that. So that's what's underneath the radical. So we end up with x equals negative 10 plus or minus the square root of negative 56 all over 6. So now let's focus on that negative 56. Here, if you look for perfect squares that are in 56, you're gonna come out with, this is the same thing as 4 times 14, obviously with the negative in there too. So that'll become x equals negative 10 plus or minus. The 4 is going to come out as a 2, and then the I comes out because of the negative, and you have 14 left inside, all over 6. Now, you guys remember, in order to be able to cancel here, you have to check these 3 spots. Those are the only 3 spots you check. The I does not matter. Whatever's under the radical can't be simplified, so that doesn't matter either. It could be any number. In this case, these are all divisible by 2, so this is going to become a 1, this is going to become a 5, and this is going to become a 3, which means your final answer here is going to be x equals negative 5 plus or minus I radical 14 all over 3. Okay. Excuse me. So, couple things there, just a review of quadratic formula. That's obviously not the one I use the most, so that's why that's on there. And then don't forget simplifying your radicals and simplifying your quadratics with that, with the 3 yellow circles. Okay. Over here, I just want to go over this again, converting the vertex, or converting function to vertex form by completing the square. So remember, we still need to take that constant and move it over, but since we're converting a function, we're not solving, you're going to leave it as y, and then you'll have minus 3 because you would subtract the 3 over, equals negative 2x squared plus 16x. So now we're going to complete the square. We have y minus 3 plus a blank equals, you have to factor out a negative 2, and then you're left with x squared minus 8x plus a blank. Watch your signs there, you guys. Negative 2 times x squared is negative 2x squared. Negative 2 times negative 8 is a positive 16. Negative 8 divided by 2 is negative 4. Negative 4 squared is 16, so that goes here. But you're not really adding 16, you're adding 16 times negative 2, which is negative 32. Remember, the only way that your blank over on the left side could be negative is if your a is negative like we have. So we end up with y minus 35 equals negative 2, and that condenses to x minus 4 squared. And then to get it into vertex form, you need to add the 35 over. That is now your k value. So your final answer is y equals negative 2 times x minus 4 squared plus 35, and that is your final answer. Okay, so a couple review things on the warm-up. Today we are going to head back to factoring. However, now we're going to factor over imaginary numbers. So this front side, these first 8 problems are all review of imaginaries, a little bit here and there. It's also review of simplifying radicals, just based on kind of what we have going on over the next couple days for notes. So we have, we want to remember that I squared equals -1. Okay, that's going to kind of guide our thinking as we go through these problems. All right, so if you take a look at number 1, excuse me, we're going to distribute here. So when you distribute in, you're going to end up with 56i plus 32i squared. Then we want to change that I squared to a -1. So we're really going to end up with 56i plus 32 times -1. I'm showing more steps than you really need to. So here you guys, remember a plus bi is the correct way to write that. So we'll end up with -32. You want the real part first, plus 56i. All right, number 2, this is a review. A lot of people struggled with this on the review packet for the final. Remember, you always start with what you know. We know that I squared is -1. So you say to yourself, okay, cool. 2 to what power is going to get me 53? Well, there isn't a number, so you're going to go to the 26th. That'll get you 52. You need one more. So now we have -1 to the 26th power times I. A negative to an even power becomes positive, so that's 1 times I. So 1 times I makes your final answer I. Next one isn't as bad. You're just combining like terms. You guys pay attention to the fact that you're not multiplying there, you're adding. So you drop your parentheses, you have 3 plus 2i minus 8 plus I. So if you combine like terms there, 3 minus 8 is -5, and 2i and I is a positive 3i. And that's your final answer. All right, over on the next one, we have multiplication going on. X times x is x squared. X times -3i is -3ix. 3i times x is a positive 3ix. And 3i times -3i is a -9i squared. So a couple things that we want to pay attention to. Even though there are i's here, these are the exact same term, 3ix, 2ix. One's positive, one's negative, so they cancel. So we end up with x squared minus 9i squared. But just like the last problem, we know I squared is really -1. -9 times -1 is x squared plus 9. Okay, which this, number 4, we're going to revisit a lot on the back. Okay. All right, a couple rationalizing practice problems. We have the square root of 75, so remember you're looking for perfect squares. As soon as I see a number like 25, 50, 75, etc., then I'm going to be looking for 25. So if you look at this, this is the same thing as 25 times 7. Okay, so you are going to pull the 25 out as a 5, and the 7 stays underneath. There isn't negative, so no I. For number 26, I'm sorry, not 26, number 6, which is 126. You're going to do the same thing here. If you take the square root here, I would look at 126. 126 divided by 4 is not a whole number, so I'm going to go to the next, which is 9. 126 divided by 9 is 14. So this is 9 times 14. The 9 will come out as a 3, so you have 3 radical 14, and that is as far as you can go with that. And then a reminder for number 7, because you have a 2 out front here, we are just going to drag that 2 down, And if you look at the square root of 112, it is divisible by 4. It's 4 times 28, but you can keep going, which I think is 16. If you divide 112 by 16, you have 16 times 7. So this is going to come out as a 4, but you would have 2 times 4, so you have 8 radical 7. So that's how you take care of it. Whatever comes out of the radical gets multiplied by that number in front. Number 8, this is revisiting our warm-up up here. Okay, if you take a look at number 8, we need to simplify the square root of negative 44. So we have 10 plus or minus. The square root of negative 44 is really negative 4 times 11 all over 8. So that negative 4 is going to come out, and you're really looking at 10 plus or minus 2i radical 11 all over 8. And then you got to check those 3 spots here, here, and here. They're all divisible by 2. So this will become 5. This will become a 1. This will become a 4. So your final answer is going to be 5 plus or minus I radical 11 all over 4. Again, the radical takes no bearing. Oops, sorry, that's a terrible box. The radical takes no bearing into the simplifying. It doesn't matter that 11 is not divisible by 2. Okay, so quick review from first semester. Now, let's take those ideas, and we're going to work on factoring. Obviously, we factored a lot. We're going to take it a little bit of a different way now. This is use the zeros, which we know are x-intercepts, of the following quadratics to write each quadratic in intercept/factored form. We know that that means the same thing. Okay, so we know that intercept form is y equals a times x minus p times x minus q, and a lot of times that's been nice and pretty with a few exceptions. Today that's going to change. This says that we have zeros at 3 and 8. It makes no mention of an a value, so you assume that a is 1. So this would be my p, this would be my q. We have y equals 1. You don't need to write it there. As times x minus 3 times x minus a negative 8. And that is your intercept form, right? That's old news. You guys could have done that. Here, we have a p and a q. P is 9i, q is negative 9i. Again, no mention of an a, so we're just going to assume a is 1 here. So we would have y equals 1, which you don't need to write, times x minus 9i, times x minus a negative 9i, and then that is your final answer, which that's the first time you've seen that written that way with imaginaries. We did it with like really ugly numbers, but just because they're imaginaries, we can still find them as x-intercepts. We just haven't really talked about, which you won't really talk about probably until pre-calc, how to graph them, but you can graph them. All right. Now, if you take a look at number 11, I want to veer off real quick, and I want to talk about if this was 9x squared minus 100. Okay. So that is a difference of squares. We talked about that first semester as one of our patterns. Okay, if I were to factor this, that ends up as 3x minus 10 and 3x plus 10, right? Because we get 3x times 3x, which is 9x squared. 30 minus 30 cancels. Negative 10 times 10 is negative 100. But remember, we talked about the importance of being able to look at that and say, okay, that's a perfect square, and I'm subtracting them. That's why that works. Well, now we have not the difference of squares, but we have the sum of squares. So I'm going to bring back number 4 from the front. Think about this. This was a sum of squares. It came from a factored form with imaginaries in it. So difference of squares, real numbers. Same question with sum of squares is going to bring in an imaginaries, and this is why. If you set up your 2 sets of parentheses here, in order to get 9x squared, we need a 3x and we need a 3x. Okay, I think we can all agree that 3x times 3x is 9x squared. Here, in order to get 100, we have a 10 and a 10. okay? In order to get rid of the middle term, we need a negative and a positive, okay? So right now, I literally have the exact same thing that I just factored over here, but I'm looking for a different answer. This is how you're going to do this. Think about this. 3x times 3x is 9x squared. 30x minus 30x cancels. That's good. 10 times 10, in this case, negative 10 times 10 is negative 100. We want a positive. So what you're going to do here is you're going to put an I with it. And in doing that, so this is your actual answer. And I'm going to kind of go below and show why that works. And doing that, you guys, if you were to multiply this out, that's 9x squared. And then you would have, obviously, plus 30ix minus 30ix minus 100 from the 10 times 10, I squared. Well, just like on the front problem, these are the exact same, one positive, one negative, so they would cancel, i's or not. Now we're left with 9x squared minus 100 times I squared, and I'm going to replace that I squared with negative 1. So you end up with 9I squared plus 100, which is what we were going for in the original. So difference of squares, same as last semester, but now when you have the sum of squares, it's literally, you guys, the exact same thing. However, you need to put an I in where those tens are, or whatever number you may be dealing with, so that you can get the positive 100 and still get rid of your middle term. Okay. If you look at number 12 is a sum, but it's not a sum of perfect squares. 12 is not a perfect square, neither is 75. However, don't forget, you could be looking at this and say, well, I can actually take out a 3 from both of those. Don't forget your GCF step, no matter what you're doing. And you will end up with 4 plus 25x squared. Now, I'm going to look at that and I'm going to rewrite that as 25x squared plus 4. I just like to have it in standard form. That's what we're used to. Okay. So now, again, this is a sum of two perfect squares. The 3 drops down. You set up your two sets of parentheses. In order to get 25x squared, we get 5x and 5x. In order to get 4, we need 2 and 2. In order to have no middle term, we need negative and positive. But if I left it like that, I would end up with 25x squared minus 4. In order to get plus 4, you make those imaginary. And then you're good. Okay, literally it's just one extra step. Okay. If you take a look at number 13, I'm going to take out a negative 1 here. I'm not going to take out a GCF in the way I typically would. I would typically look at that and say, oh, I can take out a 2. So here, if I take out just a negative, and this is why, I'm left with 100x squared plus 16. And then I still have a perfect square and a perfect square. I'm looking at this as a 2. If I was looking at this with my normal brain, sorry, you can tell I'm sick. 2 isn't the greatest common factor. Actually, what is the greatest common factor is 4. So let's start that over. I'm sorry, you guys. So here, if I take out a negative 4 here, I'm left with 25x squared, right? Negative 4 times 25 is negative 100. And then you have your x squared. And then negative 4 times positive 4 gets you a negative 16. Sorry, totally missed that. All right, so here we have the same setup. That negative 4 is just going to drop down. You have two perfect squares in 25x squared and 4. We just need to make sure that's a plus. So difference of squares was last semester, right? Same exact form, 1 plus 1 minus. Difference of sum of squares. In this case, 25x squared plus 4 means we're dealing with imaginary. So we're going to have that 5x and 5x in order to get the 25x squared. We're going to have a 2 and another 2 in order to get 4. We're going to have a minus and a plus in order to get rid of a middle term. But add in those imaginaries, because otherwise you would have 25x squared minus 4, and the imaginaries get you a plus 4, like I worked out above. All right, for number 14, our GCF there is 10. If I take out a 10, I'm left with 9x squared plus 16. And then, again, here's that sum of squares. Clearly, that's what we're hitting home today. Drag down your 10, set up your 2 sets of parentheses, 3x and 3x, gets you 9x squared. 4 and 4 gets you 16. A minus and a plus gets you no middle term, but then you need imaginaries, so it's a sum of squares and not a difference of squares. Okay. If you look at number 15, you guys, this was on here because you guys are used to seeing perfect squares, which is typically how you do this. For number 15, though, if you were trying to write this in factored form, so all of these we've put into our factored forms there. If you're trying to look at number 15, you would say, okay, well, that's not a perfect square. It's not even a sum of squares, so I can't even do imaginaries. Technically, you can. We just usually do it when it works out pretty. So if you think about it, like normally we would take the square root of this and say, oh, okay, well, we have x and x. That's going to get me x squared. We need a plus and a minus so that we don't have a middle term. And then normally, like let's say this was 16, we'd say, okay, that's 4 times 4. Let's say that was x squared plus 25. We would say that's 5 times 5. Because you're taking the square root. So if you think about it, what number times itself is going to be 3? It's going to be the square root of 3 and the square root of 3, right? If I multiply the square root of 3 times the square root of 3, that's the square root of 3 squared, so 3. This, though, if I just left it as is, x times x would be x squared. My middle term would cancel because I have the exact same binomial, just one positive, one negative. And then I would end up with negative 3. I want a positive 3, so you guys, the exact same thing applies. Throw your i's in, and remember, if they're if with a radical, put them in front, and then you're done. Okay? All right. Now, let's look at number 16, because number 16 is a trinomial, and I'm telling you to write it in factored form, and you're going to want to write small here, you guys. Number 16 is a trinomial. I'm telling you, you have to factor it, which means we need to find the x-intercepts and put it in factored form. However, no matter how many ways you try and factor this, it's not going to work, okay? If you tried, you would have 3x. You don't need to write this down. You can just watch me do it. And x. Your only options are 11 and 1 and plus, right? Well, that's going to get me 14x. Sure, I could switch. It's just not going to work. So this is what we're going to do in terms of this. If I'm saying, okay, give me a factored form and it's not factorable as a trinomial, all these worked out nicely because they were perfect square binomials. Then what we're going to do is we're going to find the x-intercepts, just like we did in the warm-up. This is why we did the first warm-up problem, okay? So let's find our x-intercepts first. Okay. And technically, you guys, we've done this before. It just isn't in this form. So I'm trying to rewrite this in factored form. So I have 0 equals 3x squared plus 2x plus 11. Okay, so not factorial. I'm not going to use quadratic I'm not going to use completing the square because of the 3 and the 2, so I'm going to use quadratic again. So x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. So I end up with negative 2 plus or minus. Again, just calculate what's going on underneath there. So we end up with negative 128 underneath the radical. Okay, all over 6. Negative 128, if I take that and I divide that by, let's see, I'm using my calculator just to speed things up. Let's see. So 128 divided by 4 is 32, which means we can go bigger. 128 divided by 9 doesn't work. 128 divided by, why am I forgetting? 16 is 8, which means we can go bigger. 128, oh, duh, divided by 64. Hello. Some of you might have been already there. Sorry, I told you, not totally on my A game. Gotta love strep throat. All right, so this is technically negative 64 times 2. Sorry it took me so long to get there. So we have x equals negative 2 plus or minus. The negative 64 comes out as an 8i. 2 stays inside all over 6. Again, reduce, reduce, reduce. The 2 inside does not matter. This becomes a negative 1. This becomes a 4. And this becomes a 3. So technically, our x-intercepts are negative 1 plus or minus 4i radical 2 all over 3. So if I'm going to write it in factored form, that's my P and my Q. Guys, can't forget about A, okay? But remember, no matter what form you're in, A is the same. So I can go back up to the original and say, cool, I know that A equals 3 because that's what it is in standard form. So if I'm writing it in factored or intercept form, same thing. A's got to be 3 as well. So we're going to have y equals A times x minus P, which is negative 1 plus 4i radical 2 all over 3. And then x minus q, which is negative 1 minus 4i radical 3. Oh my god, I keep doing that. Sorry, radical 2 over 3. Okay, so remember you have a P and a Q here. One's P, one's Q. I drag down my A. This is ugly, however, it is the intercept form, or the factored form of the original trinomial that I gave you. Okay, sorry, I'm just cleaning this up a little bit. This will be the square root of 2 and the square root of 2. Okay, so on your homework tonight, look for these patterns. They're specifically going to be on there. Okay, when you have a sum of squares, so everything up until number 16. When you have a sum of squares, it's the exact same pattern as this right here that I'm about to highlight that we did last semester. However, we need to add in the imaginaries for the sum. Okay, difference of squares mean we're dealing with real numbers. Sum of squares mean we're dealing with imaginaries. Just adding the extra I in. Literally, that's it. Okay? So if you have questions, I'm hoping to be back tomorrow morning. Obviously, please come see me. Tomorrow's lesson's real short, too, so we'll have time to go over homework questions as well.